heavy winter. I don't know, -10 and snowing heavily. All right. Hey Jeremy, I'm very happy to be here, and happy to have the chance to chat with you. Can you maybe share a little bit about your background, or like how you ended up in the blockchain space?
Yeah, I mean, I really love math, and I had been following. I had done a number of startups, and my previous startup was in the ML space. But I've been following the ideas around ZK for quite a long time, probably 6 or 7 years. But I never really felt like having looked at the math, having thought through how fast you could run ZK, it never felt like it was at the level of where it would be practical. But I knew that if you could get a fast, practical system for doing ZK, it would have a huge impact on all decentralized computing and blockchain, which I'd also been following for a while, although I didn't really have any specific involvement other than like finding Satoshi's paper interesting and watching the slow, steady rise of the crypto space. And then around in 2020, Eli Ben-Sasson came out with the Start paper, and I'd been following his work and the work of a number of other people. I read it, and I started doing some back-of-the-envelope calculations, and I was like, oh, this is going to make ZK fast enough to run in practice. So I tried to. I was actually had my previous startup had just sold to Intel around that time, and I was trying to. I started to try to convince my friends that ZK is like the next new thing. It'll be really exciting, right?
Cool.
But my friend Frank, who's one of the co-founders, I was like, yeah, you can run arbitrary programs, and he's like, well, how do you program it? Like, what's the programming like? I'm like, well, you just like, write some polynomial constraints over finite field elements. And he's like, shut up, Brustel. Like that's like the totally, no one's ever going to do that. It's like super niche. And so we talked and talked. I tried to convince him. He was completely unconvinced. And then one night we were out like having a beer or whatever, and he was like, we along with my other friend Brian, who's the other co-founder, and the discussion came up of, well, what if we built a circuit, because you can write these ZK circuits. What if we made a circuit that actually emulated an existing processor, like a RISC-V, right?
Yeah.
At which point you could run normal software inside of ZK. You could run Rust programs, C++, whatever, right? And then when I started talking to all my programmer and security friends, they were all very excited. They thought it was and so that I was like, yes, this is a good next company to start. So I started we started the sort of process of doing that. Yeah.
That's awesome. I was listening to your talk actually this morning, and it was quite funny. The little story that you shared actually from, I don't know, back maybe 25 years or something like that. Yeah. I mean, just for the viewers or anyone listening to this podcast, maybe if you can elaborate a little bit on that or share that, that's amazing.
Yeah, so I've been, I've done a number of startups, but before I started doing startups, I was really into the security space, and kind of a hacker type, if you will. So many years ago, my sort of initial claim to fame, which is part of what sort of got me enough recognition to start going and raising VC money to make companies, was really I was at the time much younger, blue hair, like a hacker hoodie
with blue hair.
Yeah. It was a reasonable look, I think. I had a number of crazy hairstyles. Some of them were pretty terrible, but at least that one wasn't bad. But, anyway, I probably should go find some old pictures and post them on Twitter at some point or whatever. But yeah. So I was living in this sort of punk rock hacker house kind of place. We had like 8 roommates. We split the rent 8 ways. It was like in a small town in the Midwest, so it was less than $100 a month for rent. So some people actually paid their rent with like plasma donations.
Could you really do that?
You really could do that. Yes. This is the wonderful thing about living out in the middle of nowhere, is that it's actually very cheap. So what's really cool is that we had a lot of time, right? And we like had some like dumpstered computers from the used computer place where they'd throw out parts and stuff. Anyway, it was a really wonderful time. But I've always loved math. I was reading math papers back then for fun as well. I read this paper out of UC Berkeley, which was about this sort of issue with the RC4 cipher, that the way that the key generation worked had some problems. And at the time, Wi-Fi was a new thing. And Wi-Fi actually uses RC4 as the method for WEP, the Wi-Fi encryption standard at the time, used RC4 as like the main mechanism for doing some of this stuff. And I was like, wait a second, does this like break Wi-Fi, right? So, me and another friend of mine who had more background on sort of the radio level and also some cool UI ideas for our little hacking program. We spent a little while writing a prototype that could theoretically break Wi-Fi, or so it would appear. And we wrote it, but the problem was we didn't have any. We didn't have enough money to go buy a Wi-Fi router. They were actually significantly more expensive at the time because it was a new thing.
Yeah.
So we ended up collecting money from a couple folks, going to Best Buy, buying it, taking it home, setting it up, running all of our tests of like our new attack, and then packing it back up and taking it back to the store, getting we still have to pay the 10% restocking fee, but so
yeah, that's
smallish price to pay. But anyway, it turns out that it actually did in fact work. So web encryption. The program was called AirSnort, and at the time, it was a pretty significant thing. We published it and put it out in open source and like contacted a couple of like the Linux Security Journal and stuff. But I didn't realize it would be quite such a big deal, because my opinion was, well, obviously everyone knew this Berkeley paper was out, so we didn't really invent anything. We just implemented it. So
exactly.
But it was Wired called and The Economist, and like it was like sort of really interesting. And eventually the reality was WEP. There was a flaw with that. There was a bunch of other flaws with WEP. It was a really poorly built standard. Eventually WEP was effectively deprecated and replaced with WPA, which is what Wi-Fi uses today, which is a much better standard. But it was definitely really an interesting and exciting time for me, certainly.
Yeah.
So
that's quite a story. Amazing.
But yeah, and then after that, I went and started a company that did basically Wi-Fi mesh networking company. That one didn't really go that well. I think we were a little ahead of our time. But so anyway, it was the beginning of my sort of journey in that.
That's
realm.
amazing. Yeah, it's really cool for me to see how with very different backgrounds people end up in the blockchain space. For me personally, I've got 10 years of UN background in the humanitarian space, finance and management, but I was kind of an idealist joining UN back in 2010 or something like that, 2009 maybe, and but then after a while I found out it's just too slow and too conservative, maybe a bit even too political for the type of impact I'd like to be part of. And then basically it was actually just around, as you said, 2020, 2021, actually late 2020 when I discovered blockchain. I was excited about Bitcoin, but actually Ethereum and the programmability was something that piqued my attention much more, because of the wide variety of use cases it could bring about.
Absolutely.
And so I said I need to dig deeper. I need to start studying, even though I have a very different background, but this is something I'd like to be part of. Yeah. And it's just amazing to see how open the space is for anyone who wants to make an impact to come in and find their way. Yeah,
I really when I started coming to sort of blockchain conferences, a couple of years ago, when I sort of realized this, the potential impact of ZK, and it was obvious that the blockchain was the space where it would have the most impact. It was really exciting to me because I think the blockchain space is composed of such an interesting variety of different people from different fields. It really is intersectional in terms of sort of the kinds of different people that it brings in, which is really exciting.
Yeah, absolutely. I mean, currently, as I joined Gevulot, I mean, back then we were mostly called Gevulot. Currently we are mostly known as ZKCloud, but the lab entity is still behind. So I joined as protocol researcher, and for me it was super, like ZK as the privacy aspect is one thing, but also the scalability side was super interesting, what it could bring about, because we had this trust-based space prior to blockchain, so to say, and then we moved to trustlessness, but you needed re-execution.
That's right.
Which brings about a bunch of tons of inefficiencies, basically. And then we are moving to, I don't know, 3.0 version of the era where we have ZK and where we can make things much more efficient. We can scale things in a much different level than before. And we are working with, obviously, as proving infra provider, we are looking into different ZK VMs. We are supporting different ZK EVMs, etc. But one of the hot topics nowadays is basically Ethereum proving, or like real-time proving of Ethereum. And if I may, I'd like to ask you about that, and like how Risc Zero is kind of progressing on that front. I've seen recently this latest version of SP1 published. I think it was late January, where 4.0, if I remember correctly, where in the blog post Uma mentions they are at around 25 to 35 seconds, somewhere around there. And I just wanted to ask you, how are things going? I remember you've, like your team in some blog posts mentioning that some circuit upgrades are about to come at some point. Where are those? How are things going?
Yeah, absolutely. So we're about also 30 seconds at this point for a full
That's
Ethereum
amazing.
block. And I actually think that, we as an industry, by the end of this year, real-time proving will be completely within reach. I think there are, so we're working on a number of very near-term performance improvements with our new circuit that we're just about to put out the release of that. Additionally, we've been working with the folks at Irreducible on the Binius proof system, which we are hoping to get out a version of our ZKVM that uses that will provide additional performance benefits. And we're also talking with Fabric as well in terms of like a hardware implementation.
That would have been my next question.
Yes, exactly. So I think that with ZK has moved, I think, from with regard to re-execution. In some sense, blockchains are a type of verifiable computing.
Yeah.
And the way they do verifiable computing is by consensus, which requires, as you mentioned, re-execution. And that's expensive because machines have to run it many, many times. We're now at a place with ZK, which we only sort of got to this previous year, where the cost of proving something in ZK is actually now less expensive than the cost of doing it using consensus.
Yeah.
And as a result, and that cost is only going to go down and down. So I think that we're going to start to see this fascinating world where we start to move from, right now, if you look at the verifiable computing using consensus, there's a fixed amount of compute in a block. And, as the demand for execution goes up, the space in a block stays constant, and as a result, it basically supply is fixed, demand's going up, so your costs just go up and up and up. What's great about ZK is that as the demand goes up, the supply can go up too, because you can verify as much ZK computing as you want. It always takes the same amount of time with proper aggregation, and as a result, what this is going to mean is that if you want to run huge, complicated, things in blockchain, it'll be no problem. Like if you want to run as the demand for computing goes up, more supply will come online. Provers will spin up, and if it ever becomes more expensive to make a ZK proof, then it like say with Boundless, which is our sort of our way to do distributed, decentralized proving. If it ever becomes more expensive to produce a proof than it costs to spin up an AWS machine to run the proof, then there's an arbitrage where you spin up an AWS machine, you get the money for proving, and you pay Amazon and you make a profit, which means that it will never be more expensive than like an Amazon on-demand instance. And we expect it will actually be significantly less expensive. Data centers and token incentives and the like. So yeah.
Yeah, I mean, it's interesting you mentioned arbitrage, because I've been thinking about this type of a different type of arbitrage which may happen later on, where there are different marketplaces or sources of demand where you can actually bid for winning proving jobs. On the other hand, there are a bunch of proof providers who offer certain capacity at different price levels. So there could actually be an arbitrage where some sophisticated I call it builder, because we call it like builder on Ethereum, who sophisticate, like specialized entities that are building blocks in an optimized way on Ethereum and then propose like bidding with the proposer through the relays. I could imagine some sophisticated entities who actually don't own the compute power, but they've been proving jobs on one side, they found the cheapest compute on the other, and it's just gonna float there. And then some kind of relay network that ensures and enables this type of super efficient communication, and an opportunity for kind of financializing.
I think you're very astute in that regard. Like I mean, to me, like one we've been sort of talking about this internally a lot, but I think one of the things is that in some ways, verifiable computing allows the financialization of compute, right? Like fundamentally, at the end of the day, if I want to get some computing done, it matters to me who's doing the computing in the non-ZK world. Like I can't just trade out Amazon for some computer running in someone's basement, because like I probably don't trust the computer running in someone's basement, and I need an SLA and I need all these other things, right? What's interesting is that ZK, by being self-verifying, means that if I say, hey, someone give me a ZK proof of this computation, it really doesn't matter who gives it to me. It just matters how fast it gets done and how cheap it gets done, right? And as a result, you create sort of a spot market for computing based on this kind of direction. And once you have that, you can construct derivatives on it. You can like actually build SLAs by having someone, for example, stake that they will get it done within a certain amount of time, or they will lose their stake, right? And all of these other kinds of interesting sort of financializations or derivative structures you can build on top of those markets, and including things like this arbitrage idea you mentioned, where maybe some financial party actually is just being very clever and selling verifiable compute to one party and buying it from another and making a profit because they're able to understand more the demand structure of things, right? So I think that's really wonderful, because what we've seen is over and over again, when you commoditize something and create an efficient market around it, that it drives down costs and improves market efficiencies, and in the end, the sort of the consumers win from this process. So we're very excited about that, and very strongly supportive of that sort of model of the
amazing
process.
May I ask you something about Fabric? We've been in touch with the Fabric team also, and looking to support the VPUs in the ZKCloud mainnet. I mean, also the current version of the network we have out. But it seems it's going to bring in a whole different cost performance metrics, so to say, or parameters that we've seen earlier. And like you mentioned, 30 seconds for Ethereum block proving. If there is a 5x increase, I'm just throwing in something that's without making changes, that's basically 6 seconds. We are at 6 seconds if you run the current circuits on the VPU. And I'm just making something or throwing out something rough, but how do you see the impact of these hardware, the specialized hardware coming online? And also you mentioned irreducible. Sorry, this is a multiple questions in one question. Like irreducible is using FPGAs, and if I'm not mistaken, they are looking to build a custom silicon, but that may be further out. If already Fabric uses or supports Binius as well, or may support the version of ZKVM, Risc Zero ZKVM, utilizing Binius, then how could these dominoes or I don't know, these match together actually.
Yeah, I mean, I think it's still a little unclear in that, like, we're actively working on building out support on these things, and we are very bullish on the fact that there will be significant both raw performance and also cost performance improvements from these sort of projects that we're undertaking with these partners. What's interesting is that it's because the complexity of a full proof system it involves a lot of different kinds of operations, different kinds of computing, different kinds of memory access. It's not exactly clear how close to sort of like the speed of light on these machines we'll be able to get, in the sense of, like, will we be able to keep all of the necessary computing units busy, or will we be memory bound? So I think that we won't really know until a little further on this year exactly what the multipliers, what the actual multipliers will be, but they could be very, very large, like 10x, 20x. Like I think that even if those are not the case, in general, the industry, just on a pure software and a GPU prover support, I mean, we've been, a 3x or a 4x multiplier on performance almost every quarter. Right,
that's quite amazing.
Yes, and it's purely just engineering, right? Like the reality is that, and there's still a lot of just straight performance engineering to be done, even with the existing model. So I think that, I in one of my talks, I mentioned this idea that, like, this is the last year we're going to be like worrying about, ZK performance. It's already getting so cheap. Like at 10 cents for a full Ethereum block, it's almost kind of silly not to just prove all of Ethereum, right? And at a penny of an Ethereum block, it's silly, right? Like, and I think that we're going to move into I think that in some ways it's going to be, I think people already don't realize how performant general purpose ZK has gotten, and it's actually, there's still a lot of room for improvement, and by the time 2 years from now, I think that it's going to be, the delta between consensus-based and ZK is going to be so vast that almost all execution is going to move toward sort of the ZK side of the world.
And do you think people will keep writing custom circuits, or where do you see the kind of product fit for custom circuits?
I think the way to think about custom circuits is the way you think about ASICs in the real world. Like, most people building most products just write software, and they run it on the fastest CPU. And some people use maybe GPUs to write the software instead of CPUs, but they're both general purpose. Every once in a while, it really does make sense to make some custom silicon. But I think similarly, custom circuits will be a rarity, and they will only be used for the truly highly specific part of the process. Like, for example, maybe for an ML use case, right? You want to run a large language model. Maybe there's some sort of custom circuit that is a tensor operation, that you build. Those kinds of things, and I think in general, one of the things we've also seen with the sort of general purpose ZK VMs is there is this idea of like building in a precompile or like some additional specialized mechanism to handle a few of the cryptographic operations. So, for example, for SHA-256 or Ketchak, we have a specialized mechanism that does not just use the general purpose thing, but that is a specialization for those use cases. But I think that by and large, there's only so many of those kind of like custom circuits that will be necessary, and the vast majority of things will be general purpose.
All right. That's a nice perspective. Thanks a lot for sharing that.
Absolutely.
Yeah. Another thing I wanted to ask, that's a bit different topic, but I've seen the Eclipse announcement last week regarding Kailua and Eclipse integrating or having decided to choose Kailua as the fraud-proof protocol, basically for their network, and it's really interesting for me. We've been also at ZKCloud, we've been writing and posting about kind of the optimistic is dead and long live ZK phrase. And how do you see the, like, okay, two things. I wanted to ask you, like, where is Kailua now, or how,
Yes.
in terms of like maturity? I looked into the docs, I looked into like the capabilities. I think it's kind of like, okay, I don't want to draw comparisons, but for me it's OP succinct enhanced, if I may say that. Sorry if I'm, if I hurt anyone. But it's kind of like, the flexibility to go from ZK proofs to full validity roll up, and all the range and hybrid setup in between that's possible, and creating basically a very gradual and tailorable path for anyone to get there, depending on their needs, depending on their market, etc., etc. It's just amazing. So I wanted to ask you where it is, how mature it is, how do you see the market, what's the interest? It's amazing to see Eclipse, for example. Type of thing.
We've had a lot of interest, and we have a number of people that are adopting it, some of which you mentioned Eclipse and so on. I think one our view is really this. We really believe that the costs of ZK will eventually move most sort of these things towards validity proofs. But I think that clearly optimistic proofs are still both less expensive, and also, we really sort of believe that, especially when you're looking at something where maybe the transaction rate is like super high, right? Where you're doing like mega gas kinds of like use cases. And, while at the end of the day, we of course want to drive, as part of Boundless and our sort of goals, the maximum amount of ZK computation, we really want to give customers the choice of when does that price difference between the optimistic route and the ZK route make the most sense for them, right? And at the end of the day, ZK fault proofs are much, much cleaner and more straightforward than the sort of existing sort of cut and choose game that's used in optimistic proving. So we believe that like ZK optimistic is a clear step up from straight optimistic. But when to go from ZK optimistic to ZK validity is really in some ways a trade-off between, what do you want your lockup time to be versus how much do you want to pay, and like this is sort of like our view is to provide the maximal flexibility to the customers and let them figure out when that makes sense. We do believe that as ZK gets cheaper and cheaper, more things will move to validity, but we want to let the market do that at the rate it wants to do it.
And do you think it's at the point of maturity where new chains thinking about launching on, I don't know, the OP stack would right away rather go with Kailua? Do you see that happening?
It's ready for prime time, I think. Yeah.
Amazing. Yeah. And what do you think about the existing ones? I think that's another good question. Like in terms of timeline, because moving out of starting off something new in a certain way is one thing, and you are not determined by what's behind. But the existing roll-ups, which have been functioning for a while, they are fine with doing it optimistically. They have been. So what do you think? What's gonna be the trigger point for them to change, or what timeline do you see there? Maybe?
I think that there is a lot of interest and motion in that direction, and I think that there is also momentum, of course, right? And I think that as we start to see more ZK and ZK optimistic things out there, there's going to be market pressure to move in that direction, especially as like ZK validity makes the withdrawal times much lower. So I think that the market will move in that direction, including the market leaders today. But at what rate? We're in the conversations with a number of them. But yeah, I guess. I don't have a crystal ball, but I do think over the next year there's going to be some significant movement in that direction. But we'll see.
Amazing. Yes. Thank you very much. Actually, I just noticed I never really introduced myself. I'm Norbert from ZKCloud. I'm super happy we had the chance to chat here, and all the best for the rest of the week.
Yes, it was a great conversation. Thank you so much. Really appreciate it.
Thank you so much.